Hi, I'm Ran Kedar. I'm CEO of Space Product Innovation.
Hi, I'm Dr. Morbaja, astrodynamicist, space environmentalist, and associate professor of aerospace engineering and engineering mechanics at the University of Texas at Austin.
Hi, I'm Raphael Rodkin, founder of E2MC Space Ventures.
And I'm listening to the Cold Star Project.
And I listen to the Cold Star Project.
And I listen to the Cold Star Project.
Most of the issues are not in the contract negotiation. Contract negotiations with the launch vehicle typically are pretty straightforward. They offer a simple transportation service, like a very sophisticated taxi. They take you from point A to point B, and they charge you X amount for that. The real issues come during what is called the interface document production, the ICD. It's an interface control document. That is a document that is going to collect all the information to manage the entire launch phase, all the preparation up to the launch campaign, the launch, and the mission until the spacecraft is separated from the vehicle. And that's where you have those meetings, people from the launch vehicle agency, from the spacecraft manufacturer, and from the customer. Sitting down together and writing everything down in this little document. Well, this is a large document. So when things go wrong there, things goes very wrong in the mission.
Welcome back to the Cold Star Project. I'm Jason Kanigan, your host, the founder of Cold Star Technologies, a data science and process engineering firm. And I'm here with Jean Paul Carnicer. That's how you can find him on LinkedIn, but he goes by Paul. He has been running a company called Telecan Space that he's been the founder of for the last 8 years. So it's been around a while. Lots of capabilities. I'm going to link to the website below in the description, and you can go there and look around. But his specialty is bus engineering, and that is a thing I don't know much about. So thanks for being here, Paul.
No, thank you, Jason. I'm very excited to be part of your Cold Start podcast.
Awesome. Well, we have a question here we know is a two-part question now, so I'm going to ask it in the two parts. One, about spacecraft bus design. What's the most important thing to keep in mind about designing this thing?
Well, the most important thing to keep in mind about the satellite bus is that the satellite bus is itself a system that is composed of several subsystems, for instance, thermal, power, structure, TT&C, mechanism, propulsion, etc. All these subsystems, they need to come together in a balanced way to deliver an optimum satellite bus. If you put too much emphasis on one side, the bus is unbalanced and it's not an optimal solution, which will result probably in an expensive bus that is with features that are actually not needed for the application. Or it could be the other way, the imbalance is putting too much strain in another subsystem, for instance, in thermal, and it cannot deliver what is intended to be delivered.
Okay, so everybody's going to be using this thing, like the spine, and yeah, if we overload it with one system, that's going to cause a problem for the others. So is there something that people who are not in charge of designing the bus tend to forget or overlook when they're coming up with design requirements? Is it that sort of whole hog piggish mentality of, oh, I need to eat all the energy or something?
Yeah, the typical problem with people that are not, I've been on both sides of the fence. I've been the designer and I've been the guy that's specifying the requirements for the designer. So I know very well what are the problems on that sense. And it typically relates to inexperience. When the person writing the requirements is an experienced person, typically they do it well. But it's a learning as you go type of process. So the more number of programs you have been written, the specifications, the better you get. There's no book to tell you how to specify a satellite correctly. So
okay.
The people that lack of experience, they either under-specify a satellite bus or the satellite in general. And the risk with that is you're getting whatever's left over in the shop of the manufacturer. And you'll end up with a satellite that doesn't have enough margins, and it will barely meet your requirements. And if there's a slight anomaly, you're going to be not delivering what your customers want.
Okay.
The other problem is when they over-specify.
Yeah.
If they over-specify, they end up with a satellite that has a lot more capability than they actually need, and then end up paying for something that it's going to be wasted in orbit. Nobody's going to use that. So those are the two typical problems I see, and I've seen in producing satellite specifications.
Okay, so that's what can go wrong. It basically doesn't have the capabilities to do what you want, or you're overpaying for too much. Too much goodness. Okay.
Yeah.
A long time ago, when I got out of college, I did some. Even though I'm not an engineer, I would design power plants, cogeneration power plants, things up to a few megawatts. Power quality was a factor. Is that a factor here, or not at all?
Everything is a factor on a satellite. So it's a system, and everything has a consequence in another substance. For instance, if you have a power failure, or you have less power than you were expecting for any anomaly, it's going to have a consequence in another one. The most immediately one is on thermal, because you're dissipating less energy. Thermal have to pick up the slack, and try to make things work with less power. There's going to be less. You're going to start diverting power that was going typically to heaters into the payload, because that's what pays the bills. So there are consequences in all the entire system.
Okay, heat is the dumping ground of the universe here as well, huh? So you have a number of courses listed on the website, and I'm curious who they're for, what kind of person best benefits from them, and what the investment range looks like.
Okay, we have two main group of courses. One group of courses is the procurement management courses. These courses, they cover the entire spectrum of anybody that's trying to procure a space asset. And it starts from writing the RSP, selecting bidders, contract negotiations, and then managing the contract all the way up to delivery. And for who are these type of courses? For everybody, either engineers or non-engineers. Typically, everybody, when we're talking about the space industry, they all automatically think about engineers. But there's a legion of non-engineers working in space programs, which are lawyers, accountants, contract managers, assistants, and so on, that they have a tremendous need to understand what is a launch vehicle, what is an orbit, what type of insurance we're getting for an orbit, what is the satellite life. They need to understand very well these concepts in order to do their jobs. And when a lawyer grabs a contract, a launch vehicle contract or a satellite contract, they have options. We're getting more power margins. We're getting options of different launch vehicles. They need to understand all this, and they don't teach that in law school, so it helps them a lot in doing their job.
Okay.
The other group of courses we do is space segment technical courses. They go from the very basic courses for junior engineers that come from different industry. They're trying to get into the space industry, all the way to very advanced courses like electric propulsion, advanced thermal, and so on.
All right. And the investment level looks like about what?
It's very flexible. We do not offer typically canned courses that are given at a certain date in a year. We offer customized courses for our customers. So we tailor them for whatever the needs that they have. Sometimes they have a small group of 3 people, and they want to learn about they're mid-engineers. They want to learn hone their skills in an advanced propulsion course. So we give them like a 3-day course. Sometimes they have a large group of like 10 people, and they want to cover the entire spectrum from basics all the way to advanced. So we prepare something different for them. But the key here is that the courses are flexible to whatever budget and whatever needs you have.
Okay. And where did you get the expertise together? Like you have to find these folks, obviously, right, to help teach some of the course material.
Yeah, most of the people, the trainers, I am one myself, have over 20 years of experience doing honing that particular skill or that particular area. For instance, I spend most of my time as a thermal mechanical engineer. So I tend to give the thermal and mechanical courses, as well as the procurement courses. Then we have experts in propulsion, we have experts in electrical power systems and so on. They've been working 20, 30 years in the industry. Some of them are retired now and they just do it for fun. And they want to give back the know-how to the next generation.
Okay. On the website, you've got a service offering. We're going to go through a couple of these. Outside testing of spacecraft. So someone will, do you go to where the satellite is, or do they send it to you, or what?
We typically don't do testing at satellite level.
Yeah.
We have smaller facilities. Typically, we test at unit level, at the box level,
Okay.
rather than at the satellite level. Depending on the size of a satellite, you need a very large chamber, a very large facility just to run the chamber. So that's the type of testing we do, and we focus more on developing testing rather than actually qualification for something that is already built and it's going to fly the next day. People, when they develop things that you want to do a test just to mitigate risk, to see just how this, the prototype works or not, that's the type of the testing we mostly do here.
Okay. Are you making something then on behalf of the customer, or do they ship you something?
Sometimes we make, we do R&D for customers. They have a specific problem they want to solve. For instance, we do a lot of R&D on thermal management hardware, heat pipes, heat straps. So they have an electronic box. There's overheating. They put nowadays 150 watt FPGAs on them, and they want to cool them down. They used to be about 5-10 watts before. So it's a huge, an order of magnitude difference, and that heat is difficult to remove from the electronic box. So we design and test this customized thermal management hardware for them.
Okay. This is Jason Kanigan from Cold Star Tech, and I'm excited to share with you a new offer from Cold Star that we are bringing out to help both space founders and venture capitalists who fund space companies. And it's on two levels. The lower level is a VC who is looking at possibly funding a space company, but they just don't get it. Right? And a lot of tech founders want to come out and create some sort of technical capability, but they do not understand business. And so you'll look and you'll go, where's the customer here? Where's the business model? And they'll go, but I want to make rockets or something, right? And it's really cool. Well, that, as we know from the dot-com era, is not a viable business model. And so you bring us in. We've got great technical expertise on the space side, folks who have done this sort of assessment before, like our technical engineering advisor, Dr. Rick Fleeter, myself in the process engineering field, plenty of other people with brains to look at this problem so that you don't have to blow your brains out trying to figure out how to make this work. And on the company side, it's a benefit for them because we will show them the roadmap to how you're going to get funded, how you will want to fund them, what changes to make to get VCs excited about putting money in. And so that's good for you. Right? The second level is at a deeper and higher level at the same time. It is for venture capitalists who have given a seed round to a company, a space company, and that has gone on for a little while, 6 months, a year, something like that. And it is time, as COVID has made it, to double down or get out. Those are pretty much the choices, right? It's time to invest further in a thing we already know, which seems to be the direction VCs are going in right now. They don't seem to want to look at new things or stop, just kill the project. And so the good news is, in that situation, there's a lot more going on. There's more meat for Cold Star experts to get in and analyze, right? You're going to have processes in place, whether they know it or not. We'll be able to flowchart those and maybe accurately document them for the first time so we can get some kind of value chain going in the organization. We'll be able to test whether the leadership is the right group of people or whether you're missing something, the strategic direction, the business model, all this stuff. So if this sounds interesting to you, reach out to us. You can email me at jason@coldstartech.com or just connect with me and message me on LinkedIn. That's probably the best way to do it. And I am excited to talk to you. The kind of transformation that we're able to offer here is beyond anything you'll see out there. And as a VC, this will save you so much time and energy, right? Like if you're a VC and you've got 100 companies to look at, you've got 3 days a year to look at each one maybe, right? That's not really good enough, is it? Wouldn't it be better to have experienced, expert space people who understand space, right? Look at this investment and tell you, here's a grade. Right? Here are several grade areas. Is this thing ready to pour gasoline on the fire, or is it just going to go up in smoke? This is Jason Kanigan from Cold Star Tech. Let's get back to the interview. So if you're putting it together, it's no problem. I was thinking you guys are based in Canada. It's shipping things across borders that are technology based is not always the easiest thing to do. Is this ever an issue, or do you just go, look,
Yes,
we'll design it?
it is a difficult, it is a problem. Not to get raw materials and parts itself, but once it's assembled and has a space label on it, it gets more difficult to cross borders. For even stuff that we've designed, for instance, we've designed things and we send it to the US and now automatically becomes ITAR. And they can ship it back to us for any refurbishment or anything else, although we designed the entire thing. We built it, but all of a sudden it's out of our reach anymore.
Right. It just transforms into something else. Okay, let's talk about satellite program monitoring. How often are subcontractors holding up the project schedule?
I'll say most of the time, and it is not for bad mouthing the subcontractors. It's hard; they have a harder job. Well, the problem is at spacecraft integration level. Typically, the big players, I don't want to mention companies now, but they have a very well-tuned process to put together a satellite. It's not the first time that they do it. They've done this, especially in geocom satellites. They've been doing this for many years now. They know how to do it. They have very well-oiled machinery for that. But always the problem comes at the subcontractor because they provide all the parts to put together. So there's always some sort of problem. Either a worldwide. I remember once there was a worldwide shortage of Captain. Captain is the yellow tape that you see around the satellite. It's just like the duct tape of space. It's a very generic material, very generic thing that's used. Everybody uses that. And there was a worldwide shortage of that. So all the schedules of the satellite level were delayed or at risk to be delayed because of shortage of Captain. There was a shortage of Ka band amplifiers. These amplifiers are used for satcoms. And all of a sudden, they're making these big satellites. They were taking hundreds of them. So there was a fierce competition trying to get a hold of these tubes. There's also problems of obsolescence. Nowadays we see it less, but sometimes there is an anomaly in orbit of a specific unit, and that affects all the units that are similar or have similar components to it. So you cannot integrate a unit that is suspected to have a problem. So that brings delays too. So yeah, most of the time the delays are on the suppliers, but they do have a more difficult job.
Okay. And one of the things that you say you work on is interfacing with the launch vehicle agency. What kind of issues do you encounter there?
Most of the issues are not in the contract negotiation. Contract negotiations with the launch vehicle typically are pretty straightforward. They offer a simple transportation service. It's like a very sophisticated taxi. They take you from point A to point B, and they charge you X amount for that. And they have some options, but usually the options are not that, like giving you a better internet connection at the launch side, some other features to have your people working in more comfortably during the launch campaign, but they're not that significant. The real issues come during what is called the interface document production, the ICD. It's an interface control document. That is a document that it's going to collect all the information to manage the entire launch phase, all the preparation up to the launch campaign, the launch, and the mission up until the spacecraft is separated from the vehicle. And that's where you have those meetings, people from the launch vehicle agency, from the spacecraft manufacturer, and from the customer. Sitting down together and writing everything down in this little document. Well, this is a large document. So when things go wrong there, things goes very wrong in the mission. For instance, there's a mission to a large satellite manufacturer that the satellite ended up in the wrong orbit. It also determines how the process during the launch campaign. A satellite got damaged because somebody moved the crane and hit the satellite with a crane. So this is the critical moments when this document is being created, and a lot of people overlook that.
Okay. Are there any other places during the process that you find that your company is helping out customers the most with?
We also help a lot during contract negotiation for satellite. That's a key point for that. because that depends. You have to make sure you put all the clauses that you need to protect yourself during the both. You're not buying. It's not when you buy buy a car. Just go to the dealership. They keep you sign a couple of documents. They give you a key. And you go out. When you buy a space asset, it's a very different process. You need to be involved to make sure you're getting what you're paying. So you need to be very involved in the contract right at the beginning in the contract negotiation phase, ensuring that you're going to have the visibility you need, all the controls, the audits on the process. You also have to make sure that you're going to make sure that it's written down in the contract, all the hardware you're going to get, what is the qualification of that hardware, what is the product assurance process behind that hardware before it gets put into a rocket and launched. Because if you don't write that down, you're getting whatever's left over in the shop, and you may be fine, but typically when you pay for a salve, you're paying for a top quality salve, like not whatever is left over.
Right.
Because nobody else wanted it. Everybody else rejected it. You don't want that battery or that liquid apogee engine. You want the one that had the top mark, not the lowest mark.
Okay. And for anybody wanting more information on space insurance, I did an episode with Bob Weirdy of Marsh, and we went into quite a bit of detail on how space insurance works there. Okay. So a lot of contract negotiations and making sure that folks are getting what they think they are. And you guys help them turn all the rocks over to see, hey, did we actually look under here? There are a lot of engineers out there today who are starting up space companies. They're trying to get funding to develop technical capabilities. And I'm curious what you wish that these new founders would know about starting a space business, given that you've been in the industry a long time.
That's a very interesting question. I think nobody knows really the answer nowadays. We are, I mean, private space is still a baby. It's not been that long. And if you asked me about a couple of months ago, I would say that because we work a lot with startups, and we see a lot of that. They have very good ideas, very good momentum, but they didn't get to the finish line. That 2 months ago, I would say it's a problem of scale. But with what happened recently with OneWeb, I really had to rethink what I would say. So it's very difficult. Everybody is trying to figure it out. Some have been able to do it, like Elon Musk with SpaceX, but I think that he was at the right time. He was very fortunate. I mean, he had a great idea. He has obviously he's a very smart person and driven person, but he was there at the right time with the right idea. I've been procuring launch vehicles for a very long time, and I've seen a lot of people with even better ideas than Elon that had failed because they didn't have it ready at the right time. So timing is very important. Timing is very important, and when they plan, they should plan for sustainability rather than thinking about 10, 15 years ahead, because they might not even get that. We need to pay bills every month. So make sure first you have money enough to pay the bills every month, and you'll get to the 10 years.
And when you've got $1 million a month burn rate, that money disappears really fast.
Yeah.
All right. Where can people go to find out more information about you and your company, Paul?
Well, obviously our website and LinkedIn, there are good resources. There's our contact information. Please give us a call, contact us. We love to hear about your problems. That's what we are about, to solve people's problems and help them to go through their problems. Awesome.
All right. Well, I'll link to the website in the description below. My guest today has been Jean Paul Carnicer. He goes by Paul, and he's the founder of Telecan Space. It's been great to hear from you and get some of that nitty-gritty feedback of what it actually takes to build satellites. Thanks for being here.
No, you're welcome. Thank you, Jason. Have a great day.
Hey, this is Jason Kanigan, the host of the program. Thanks a lot for listening to the Cold Star Project. If you want me to send you new episodes of the Cold Star Project so that you don't have to go hunting around for them or watching YouTube or anything like that, go to this page, coldstartech.com/MSB, that's short for Make Space Boring, which is what we're all about, and drop in your email address there, and I will be able to do that for you. Make Space Boring is another little show that I run. It's a shorter format, quick interviews, and news of the day, and sometimes an update of who I'm meeting and what I'm learning in the space field. It's on the same Cold Start Tech channel. Speaking of which, on the YouTube channel, I can do something I cannot do on the audio-only version, which is add playlists. And so there may be topic area playlists on the YouTube channel that you would be interested in digging into and going down the rabbit hole and learning more about. For example, space law and policy, space situational awareness, lunar mining and construction and fun stuff like that. So go check that out. That is at coldstartech.com/play. That's the short link to get there. Anyway, thanks for listening, and I look forward to talking to you soon.